Something is wrong with our planet. This is not a guess. This is not a theory. It is a fact, supported by an array of small, quiet observations that, when taken together, paint a deeply unsettling picture. The very systems that keep Earth stable and habitable are showing signs of stress and strange behavior. And yet, the world's attention is elsewhere. Our news cycles are consumed by fleeting dramas, while the ground beneath our feet, the core at our planet's centre, and the magnetic shield above our heads are all in a state of flux. The silence on this issue is a danger in itself, a failure of imagination and urgency that we can no longer afford. We must wake up. We must pay attention to the signs. They're all around us, if we only choose to look. The world is a complex machine. Its parts are interconnected in ways we are only beginning to understand. The heat engine of the inner core drives the magnetic field. The magnetic field protects the atmosphere. The atmosphere, the oceans regulate the climate. When one part begins to behave unexpectedly, the tremors can be felt throughout the entire system. What scientists are now observing are not isolated incidents, but a series of related events. The changes deep within the planet are linked to the changes in the shield that protects us. These, in turn, make us more vulnerable to the tempests of space. It is a cascade of risk, one that is building slowly, quietly, and almost entirely out of public view. We are told to worry about sudden catastrophes, an asteroid strike, a supervolcano eruption. These are cinematic and easy to grasp. They offer a clear enemy and a dramatic storyline. But the threat we face now is more subtle and perhaps more profound. It is a crisis of slow, creeping failure. The decay is not happening in a single explosive moment, but over years and decades. It manifests not in a bang, but in a series of quiet readings from scientific instruments, in anomalies that grow a little larger each year. At the very centre of our world lies a solid ball of iron and nickel as hot as the surface of the sun. This is the inner core. For generations, we believed it spun slightly faster than the rest of the planet, a constant engine in the heart of the machine. But recent scientific findings have challenged this simple picture. Researchers, analysing decades of seismic data, have concluded that the inner core's rotation has slowed down relative to the planet's surface. Around the year 2009, its spin seemed to pause and may even be reversing its relative direction. This is a profound observation. It tells us that the deepest, most mysterious part of our planet is not a constant. It is dynamic and subject to change. Scientists are careful to note that this is likely part of a natural cycle. The slowdown and apparent reversal might happen every few decades, a kind of planetary wobble deep within the Earth. In this view, it is not a sign of imminent doom. For centuries, sailors and explorers have relied on the Earth's magnetic field. The compass needle points north, but that truth is becoming less simple. The magnetic North Pole is on the move. Historically, it drifted slowly across the Canadian Arctic. In recent decades, its pace has quickened dramatically, racing towards Siberia. Experts have had to update the world magnetic model more frequently. This has real-world consequences for navigation, smartphones, military operations. The rapid drift is a measurable sign that the field-generating processes are in flux. It's a surface symptom of deeper turmoil. There is an even more dramatic sign: the South Atlantic anomaly, a vast and growing region, stretching from South America to Africa. The magnetic field here is exceptionally weak, a dent in our armour. Since 2014, the anomaly's area has expanded and its weakest point has deepened. Scientists have observed it beginning to split into two separate weak cells. Beyond the specific regions of the moving poles and the South Atlantic anomaly, there is a broader, more global concern. The overall strength of Earth's magnetic field has been weakening. Measurements taken over the last 2 centuries show a clear downward trend. Scientists estimate that the field has lost roughly 9% of its strength on average over that time. This decline is not uniform. Some areas have weakened more than others. Recent measurements, even over the past 6 months, have shown significant weak spots emerging over the Western Hemisphere, while other areas have seen a slight strengthening. This weakening matters because the magnetic field is our primary defense against the harsh environment of space. It deflects the solar wind. It also shields us from high-energy cosmic rays originating from distant supernovas. A weaker field means more of this harmful radiation can penetrate deeper into our atmosphere and reach closer to the surface. For now, the atmosphere still provides ample protection for life on the ground. But for astronauts and for our technological infrastructure in orbit, the risk is immediate and growing. It happens while the Sun, the source of most of our space weather, is entering a more active phase. In February 2024, a single massive sunspot unleashed a furious barrage of solar flares. When they are aimed at Earth, they can have significant impacts. A strong flare can cause radio blackouts. A major coronal mass ejection can trigger a powerful geomagnetic storm. While our attention is drawn to the skies and the deep core, another critical Earth system is showing signs of alarming instability: the great ocean currents. The Atlantic Meridional Overturning Circulation, or AMOC, is one of the planet's most important heat-regulating systems. It acts like a giant conveyor belt, carrying warm, salty water from the tropics northward to the North Atlantic, where it cools, where it sinks, and returns southward in the deep ocean. Vital for the relatively mild climates of northern Europe. It also influences weather patterns across much of the northern hemisphere. Recent scientific studies have delivered a stark warning. The AMOC is weaker now than at any point in the last 1,000 years. This slowdown is believed to be driven by the melting of glaciers and the loss of ice sheets in Greenland. The influx of cold, fresh water into the North Atlantic makes the surface water less salty and less dense, inhibiting its ability to sink and drive the deep water circulation. Some models now suggest the AMOC could be approaching a tipping point. The consequences would be catastrophic and global. Taken together, they constitute a planetary emergency that is happening in slow motion. The Earth is speaking to us. It speaks in the language of seismic waves, of magnetic field readings, of ocean temperature data. The inner core slows, the magnetic poles wander, the shield weakens, the sun rages, and the ocean currents falter. They are not hypothetical future events. They are active processes, measured and documented. It is a complex, interwoven crisis of converging risks. The slow, quiet nature of this crisis is its greatest danger. A slow, steady accumulation of stresses until the system can no longer cope. This means funding long-term, continuous monitoring of Earth's vital signs, from the deep core to the edge of space. It means building more resilient infrastructure, especially power grids and satellite networks that are vulnerable to space weather. It means having clear, public plans for dealing with the consequences of system failures. For scientists, it is a call to speak clearly and directly about these risks, to bridge the gap between the laboratory and the public. For leaders, it is a call to invest in the science and infrastructure that can protect us. For the media, it is a call to cover this slow-motion crisis with the same urgency given to more immediate dramas. And for the public, it is a call to pay attention, to ask questions, and to demand that these hidden dangers are brought into the light. We cannot afford to be the generation that saw the warning signs and chose to look away. It is time we started telling each other.